All right, everyone. Thanks for joining in.
Hello.
So, well, looks like a busy day. Lots of folks joining in, which is awesome. So, a couple of things we are going to do today. One is let me try and show you some of the tricks that I've learned over the years in making sure that schematics are easier to understand and follow. A lot of open source designs I sometimes run into, the schematics are a confused mess and takes me a long time to even figure out what's going on where. So some best practices in that probably helps. So I'll try and show you some of the things, some of the tricks that I have picked up over the years. And then we are going to have, let me see if I can get his name right. Braden, is that right? So Braden is going to show us how to do fancy art on PCBs. If you've seen the work of people like Andrew Sova, you know what I mean. Really beautiful looking boards which use a combination of FRP, copper mask, and silk screen to get amazing artwork onto PCBs. It is a little bit tricky to get that done, so thankfully Braden is going to show us how to get that done today. Okay, let me start with also, if you have questions, just unmute your mic and ask me, because I'm not sure if I'm going to be able to keep track of messages today. So if you need to ask a question, just unmute yourself, ask it, and then I'll see how I can reply that. Let me start off with my live stream. For those who are joining in today for the first time, I need to use entire screen sharing, mainly because KiCad is a bunch of separate programs. So I can't choose one application window and share that. So here goes, share, and here's my infinity mirror. And let me start off with KiCad. Here goes. So let me show you what I mean by opening an earlier project. Where is it? So this schematic is from, let me see, 2012. So roughly 8 years old. And as you can see, it's crowded, it's kind of complicated, and it's not really easy to get a very quick idea of what's happening where. There are some parts on the main sheet, and then there are additional subsheets like this one. This is just the LED matrix. This one is the power supply and all kinds of header pins and an RTC. And this is something I'd like to talk about later. I added a sheet that holds basically placeholder footprints for mechanical parts. In those days, we didn't have proper BOM management in KiCad, so I would add this so in order to create a more filled out BOM for things like these. The blocks you see are essentially acrylic cut pieces, and these wouldn't reflect in a BOM if they weren't listed over here, so I would make that. But other than that, kind of a confused state of affairs. Not easy to make out parts from wires and nets, for example, things going everywhere, and so on. So compare that with a more recent project, something I did early last year, probably even been working on it this year. This is from this year. As you can see, much cleaner. And you can see, obviously, the first few things. I've started adding blocks of parts. naming them. For example, here's the I2C header, Spark Fun Quick Style. Here's the light sensors, again in a block. Here's the push buttons and so on. So the subsheets have these components. So some of the changes you'll notice is the schematic symbols have a background color and thicker outlines. This makes it easy to kind of identify them in this whole crowd of parts. This do the same for transistors, same for the voltage regulator, the capacitors, resistors over there. So this makes it easy to identify the parts and in a large sheet. So that's just the RTC. The other thing I did was on the mechanical sheet, I added, because I needed to remember these dimensions when I started work on the PCB. So I added dimensions for the mounting holes that I need to be careful of when I replicate this on the PCB. And the locations also refer to the actual live location. So these same holes would be at the same locations on the physical PCB. Let me open up the PCB so you can see what it looks like. Takes a while. This one is a big board. Okay, there it is. So here's the thing. Let me fill out the pads, get rid of the drawings and all the stuff that we don't need. Fab layers. Don't need fab layers. Don't need the courtyard layers. Okay.
Can those physical layouts on the schema editor of your PCB holes be taken straight through to the PCB layout editor, or is it just a cosmetic convention to help visualize?
No, the locations are cosmetic, but I've added dimensions so that I know when I'm putting them on the PCB layout where they need to be. So the crosshair at the center of the board, and then distances relative to that. So this is just for my kind of information. Makes life easier for me. So I know around the center mark of the crosshair, the vertical spacing is 3 inch on each side, 3 inch horizontally as well, and so on. But yeah, these were cosmetic, but I know exactly where each hole needs to be. Quite often with mounting holes, it becomes easier to get confused about which hole is at which corner of your PCB, because they could be, let's say H1, H2, H3, H4, but it helps to know in which corner they are located: northeast, northwest, southeast, southwest, and so on.
Yeah, it's a nice way to do it.
Yeah, okay. Before I do that, let me get rid of the things that are giving me these messages. WhatsApp needs to go. Hackaday needs to go. Okay. That'll be quite enough for a while. So let me talk about some of the things. So one way is obviously to add blocks like this that are isolated islands in your schematic. They are connected to the rest of your schematic through net labels like MISO, clock, and reset, and so on. I also add a description for the block, like in this case, this is the SPI header, and any notes that need to be taken into account when you're looking at this particular header. With the current versions of KiCad, you can right-click on a line, and when you do edit, you get some parameters to control the appearance. So you can change the width to 15 and make it a different color. Let's say red 255 and blue 0. So that turns this line into a different color and a different thickness. You can also actually control the line style, so solid, dashed, dotted, and dash dot. So this is kind of handy when you want to mark off certain parts of the schematic and give it a more aesthetically pleasing look, easier for someone to identify what you're doing. So one is make blocks like this. The other is, let me edit this particular symbol. The other is to edit your symbols. So, okay, here's the symbol editor. Is to edit the symbols themselves. There are two properties that are helpful. One is editing the line width of any outlines that you're drawing. And this works with whether you're drawing a circle, a rectangle, or individual lines and arcs. So you can change line widths, for example, this is 20. So you can change the line widths like this, bring it back to 10, and you can do either a background color or an outline color. Background color provides this nice yellow fill to the object, and if you do fill the foreground, then it takes the foreground color like so. So that's another nice way of making parts that let me show you the library since I'm here. So all of the parts, that's a voltage regulator with a background and a thicker outline. These are all regulators. That's the smart APA102C, the in your pixel. I've put a marker on pin 1 because with some devices, for example, if you take the WS2812B, the notch is on pin 3 on the device, so it kind of helps to get that cleared out over here. That's the Atmega barrel jack. I haven't done much to it, RTC, but here are the connectors. That's the USB to UART bridge, crystals, polarized and non-polarized capacitors. Here are the connectors with the filled rectangles. That's the RTC chip and so on. That's the ESP. I've shown the antenna, the F antenna, or whatever it's called. And so on. So this is one way of, making sure your schematic is easier to understand. Break it up into blocks, outline them, give them some kind of a descriptive text, and add any notes that you would like to add them over there, like so. The other one is, of course, to use subsheets like I've done over here. Subsheets make it hierarchical sheets. That makes reading a schematic much easier. When you take a PDF print of this, you get each sheet on its individual A4 sized page. So, for example, this one would be a separate sheet by itself. And the thing for those who are kind of new or haven't played around with the hierarchical subsheets, what matters is, sorry about that, is adding these hierarchical labels. A note of caution, it helps to always use hierarchical labels rather than global ones. Globals tend to mess things up if you are not careful with how you use them. An example of a global label is your power signals. So, for example, 5 volt is a global signal. My ground is a global signal, and so on. So these go through every sheet, no matter where they are used within the hierarchy. Hierarchical labels are relative to this sheet and the main sheet that it resides within. So here's all of the hierarchical labels that are embedded within this sheet called ESP_power_UART. All of these labels, they get pulled out here, and then using wires and net labels, I connect them to either other sheets, which are subsheets, or use it within the main the top sheet in the hierarchy. So that's another way to keep things clean. You know which labels are going in and out of this sheet for every sheet that you're using. So compared to global labels, this is much easier to understand in terms of signal flow. The other way to keep things clean is here's one sheet that has 8 and 816 smart LEDs, and the same thing is repeated for 8 times, like so. And if you want to use that, let me open another project instead of this and show you how that works. Projects. Next slide. So here's something similar. It's using 5 hierarchical sheets. Each sheet has 5 of these neopixel LEDs, APA 102s. And if you zoom in and look, you will see that the row names are different. The sheet names are different for each. This is row A, then there's row B, and there's row C, and so on. But the schematic name for all of them is the same. This is row underscore A.sch, and it's the same for all of the others. So what's happening is KiCad is using just one single sheet. You don't have to draw it 5 times, but you can reference it 5 times by giving it different sheet names. So that makes life easier for you. The important thing when doing this is to make sure that you don't use any specific net labels within your sheets, because those would get carried forward to all of the other sheets, and that will create conflicts. So you don't want all of these connections connected to each other. And so you need to use hierarchical labels and leave it at that. Don't put any net labels inside of hierarchical sheets that you're going to repeatedly use. That's just one thing to be aware of. But other than that, it's a really nice and clutter-free way of designing repetitive sheets, for example. So that's another trick I use. I sometimes throw in a block that includes all the logos, which I will have to put on the PCB. So this one's going to have the Violum logo, it's going to be Open Hardware logo, and so on. So instead of just putting logos directly on the PCB without a reference to a schematic, I like to make things clean by doing this. This ensures there are no errors when you run ERC or DRC checks, for example. So these are some of the kind of tricks I use to make, let's say, easy to understand schematics. If you're new, one of the important things to do is use the setup tool, the edit page settings, and make sure you propagate these to all the sheets you're using, including all the other sheets that are within the hierarchy. So there's an export to other sheets setting. Make sure you choose that. If you want to put the correct time, push that to this sheet. If you have revisions, add that title and URL and so on. And then push them so that the changes appear in all of the main sheet as well as the subsheets that you're using like this. So all of this goes a long way in kind of making sure that someone else who is looking at your open source project through GitHub or whatever else finds it easy to understand the flow of signals and information, and is able to figure out for themselves how things work instead of bugging you with questions about, hey, where's this signal going and what's the purpose of this device and so on. So I thought I'd just put this across. If there are any questions, I'm happy to take them. Let me stop sharing my screen and get back to Jitsi. Here I am. All right. Any questions, people? Jatin, go ahead. Just unmute and ask what you need to ask.
Hi. I want to know what is the difference between global label and net label. I mean, can we use global labels instead of net label when we have just one sheet?
You can. So here's how it works. If you have a global label, no matter where you put it, it appears everywhere it gets used. Okay, so let's say you have a ground pin. It's obviously going to be global. It appears in the main sheet and in the subsheets or the hierarchical subsheets. The disadvantage of using this, let's take a signal. Let's take a clock, for example. Okay, you have clock in one sheet and you have another. Let's say you have a main sheet and you have two subsheets, and your clock is originating in a subsheet. If you make it global, you don't have to. Let me start off KiCad. Okay, share my application window. Okay, so if it's, let's say I'm in the subsheet and I include a global label over here that says test uh, clock, for example. I put it here. Uh, I can bring it inside of this sheet by referencing, okay, because I'm using the same sheet, this is probably the wrong place to show. But once I have a global sheet, global label embedded here called test clock, it's also available over here without actually, you know, bringing it out through this system of adding net labels and hierarchical sheet labels, which means you might sometimes miss referencing those global labels. It's a bit of a tricky thing if you end up with a complicated schematic. A global label is visible everywhere, so it doesn't necessarily appear in this kind of bring out over here as you see. And that means you could either misconnect them or leave them unconnected. Obviously, when you run an error check, you might catch it, but not always. The general consensus from everyone I've heard is try avoiding global labels as much as you can, except for using them for, let's say, power pins. So 3 volts, 5 volts, ground, and so on. Anything else you want to use, try and use hierarchical labels. Does that make sense?
Yeah, yeah.
Okay.
Thank you.
Okay, let me stop sharing. So, all right, Braden, do you want to show us how to do nice looking, fancy artwork on PCBs now? I hope he's around because I can see he's here on the list. Meanwhile, anyone else have questions they need to ask? I'm happy to answer anything that is absolutely unrelated. If it's something to do with FreeCAD, I can take a shot at that as well. Okay, Braden says he's attempting to talk, but we don't hear him yet. We can't hear you yet, Braden. Okay, you can try going into settings because it lets you check your
Yeah, I'm not hearing Anul either. Okay. Okay, I'm not hearing anybody at the moment, but I have a funny feeling somebody's hearing me. Okay, but I don't hear anybody else.
I was on mute.
Oh, okay, very good. So now
We can hear you clear.
thank you very much. Now I took how to take screen share, and then we should be in good shape.
There's an icon on my lower left screen. It might be on yours too.
Lower left. Oh, there it is. Thank you very much. Share audio, share entire screen. So I'm going to pause for just a moment. If anybody can just quickly confirm they see a browser with a picture of a strange looking dog.
Yeah.
Yeah, we can see it.
Okay, very good. I'm going to quickly start out. So what got me started on doing artwork, as it were, for PCBs was last year around the holidays. A number of people started creating Christmas ornaments, and then I started seeing some of the schematics that were being done and the PCBs that were being done where light would shine through the substrate of the PCB, because they removed all the copper and they removed the solder mask and they did some other things. My first example that I needed to create was actually for a project. It's taken me almost a year to teach myself enough. And it was a fairly complex one. You'll see it here in reverse, and I'll explain that in a minute. But this is an electronic challenge coin I've been working on, and doing this entire layout and then being able to tweak it and edit it was actually quite a challenge. And so I learned how to use Inkscape to first create the artwork and then how to then put it onto a printed circuit board. Subsequently, I started doing things like a Christmas ornament. Now we're getting a little more complicated. There's a really interesting piece of software called Zebra Trace, which will let you do this sort of moire effect to get just using black and white, being able to get these shading kind of techniques. And then you'll notice on here, in addition to the actual silk, which is the purple, there's also spots where I remove copper and or I remove solder mask so that the LED will shine through. Here's another quick example. And then the latest one I'm working on is actually this one, which is interesting because it's going to incorporate LEDs that shine through the printed circuit board, as well as silk layer and touch sensors. But let's actually get into, I'll close this real quick, and I can close this real quick. Let me start with, here's the schematic, pretty basic. It's using an AT Tiny chip. In this example, it's got a little piezo buzzer, and it's got Charlie plexed LEDs. Nothing overly fancy, but what I do have on here is I have just a component. In this case, it's nothing more than a mounting hole, though it will have no mounting hole when it's done. But this allows me to make sure that I attach my artwork before I start working on the actual circuit board. So the first step that I want to do is, this is Inkscape. For people who aren't familiar, I'm not going to go into a lot about Inkscape, but I am going to show some of the tricks that you can do. There are two pieces to this that I use. First is Inkscape, and then there's a plugin which can be added to Inkscape, this SVG to Shenzhen, which will do most of the heavy lifting of doing the conversion. But the first thing I do is I just create my artwork without actually touching on that particular. Make this big. There we go, and there we go. So what you see here is I've just created sort of an outline. That will actually end up being the shape of the printed circuit board. So I want something that isn't just a rectangle. I want something that's kind of interesting. You can import text. You can do interesting things with text and font. As an example, let me just jump back to my footprint for a moment. When I showed you, just a moment, where is it here? When I showed you this, these symbols right here are actually a font. And the advantage to using these as a font as opposed to trying to import little tiny images into there or using other little SVGs is I can actually do things like flow around a circle. I can attach them to a line. It's also what I did on this one. That text right there is actually following a line. So I can create a Bezier and move the Bezier around and the text will just keep wrapping along that line. So back into Inkscape, that's the advantage of using symbols. The disadvantage of using symbols is you're not going to be able to do things like, if I want to remove the copper here, really the text and the symbols work great if you're working on the silk layer. And then I just toss down some circles down here so that I can give you an example of how to remove stuff. But my first step here again is I just create in Inkscape a series of objects, a series of text, and I try to make everything black and white, but it doesn't really matter at this point. It is. If you want to color code things so you can remember them, that's cool too. And the outline of this, just to give you an idea, we're working on something that's 70 by 50 millimeters. So the way we use this plugin right here, the way I use it, is I now create another Inkscape SVG, and then I start the extension, and it says prepare. This will actually do a lot of the work of creating, and you'll see over on the side in a moment, the layers that we want. So I want this to be 70 by 50. And close that out. And what you'll see now over here that it's done is it's created a bunch of layers for us. So there's an edge cut layer, back copper, back mask, silk, front copper, front mask, and silk. And what I want to do is I want to now import that piece of artwork that we just did. And let me just set it at 0, 0. And it's there. So I now have imported it in, but a lot of times this artwork is going to be on the back side of your printed circuit board, not the front. And this is why I do all my artwork first in one SVG file and then I import it, is because now it's very easy to take the whole thing and I can flip it. So I've now flipped the whole thing and I can start working with it. So the first thing I need to do is I need to ungroup things because I'm going to put stuff on different layers. Right now it's up on the drill layer, which is not where we want it. So the first thing I want to do is I want to take this and I want to move this to my edge cut layer. So now if I turn my edge cut layer off, you'll see that goes away. Next, let's take all of this text and I'm going to move it to my backside silk layer. And it says disabled, and I'll change that in just a moment. So now if I hide that, you'll see all the text goes away. And let's say, for instance, we just want all of this to also just be on the back silk layer for just now. And we move those to the back silk layer. Done. Okay, so if it says disabled, it's not going to actually get generated when we're done. So the next thing I need to do here is say I actually want to generate my back silk layer onto my footprint, and maybe that's all I really need. Whoops, get that fixed. There we go. So now what I have is I have an edge cut layer with an outline and a back silk layer with everything else. So okay. So the next thing we do is we go in here to extension, we run the extension, and we just do an export. And the only thing that's a little confusing here is this remembers whatever the last path is you worked with. So you have to keep changing this, or put all your footprints in one place, which we learned isn't the best way to do it on a project by project basis. So PCB art demo, there we go. Apply, it'll do its thing. This just sort of waits and tells us that it's actually trying to compute. It's done, and now we close. Now what I can do is I can go back to here, and I can now assign a footprint. Oops, there's my footprint selection. I'll bring this over here. And since I already had this open, it's not showing. Oh no, there it is, my artwork. So there's my artwork. And you can see in here, there's my edge cut layer, and here's my backside silk. So we do a quick assign, and we do OK. And at this point, the artwork symbol, footprint, is now on there. That particular, right there, that little mounting hole is no longer a hole. It's just the artwork that we want to do. And so now let's quickly go and start our schematic. Not sure why that's there, but let's just get rid of all that. Oh, because I copied this from another project. There we go. Let's do this the right way and generate our netlist.
How did you prevent that artwork attachment hole from being a hole?
So the way that the mounting hole becomes a hole is by its footprint. And since we've now changed that footprint to be something completely different, it no longer has a hole in it. So if we went and actually looked at this, that is the footprint, as opposed to it being a 3mm mounting hole or a 2.54mm mounting hole.
I see. So you just put a standard mounting hole on the schema and then change the footprint associated to it, and that turns it into artwork only placement.
Yeah. Yeah. Originally, I wasn't doing that, and I was adding the footprint to the printed circuit board within PCB New. But then, if for any reason I ended up doing a refresh of all the footprints, I lost that part.
Yeah, that's exactly the problem I was having.
Yeah. So all I do is I just put a little, a placeholder here, so it reminds me to generate the artwork, and then I can come over and I can actually start this. I can import my netlist, and you'll actually see there it is. So now we can just take all this and we can drag it into. Oops. Let me zoom out real quick. Grab all this and move it onto my. There we go. And since we're working on the front copper layer for the placement of all our objects, of course, this is currently, flipped around. So one of the things that is important to do the artwork first, and this was a mistake I made early on, was if these are going to end up being used, and I'll show another example of this, where these you actually remove both the copper and the mask, you want to know where you want to place your LEDs first, right? So if I want to place an LED so that it shines through that hole, I need to know where that spot's going to be, right? And so I want to be able to do these kinds of things and move these around. I'm not going to position all of them, but you get the idea. You know, so for instance, in another example, I'm going to take this and I'm going to actually make these so that they're visible. You might put a bunch of LEDs around that logo so that the whole logo shines. You know, so maybe what I do is I want to, you know, put a few of these in here so that this whole logo can shine and you know, be lit up. I'll just place these real quick.
What type of LED footprints are you using to shine through the board rather than shine away from it?
There you go. So you might have seen that picture I showed from the browser. These are what they call right angle LEDs or side light LEDs. They actually lay over on their side, and there isn't a very good footprint for this. And I'll show you the two footprints that I've created, and the pros and cons. There's a couple of issues. So when I first created the I'm just going to grab the rest of these and just stick them somewhere in the middle of the printed circuit board for now, just so that everything is in here somewhere. And it doesn't matter, everything's going to be overlapped. So let's quickly go to the footprint editor, and I'll show you the two. We already have it here. Cool. So this SONGXI Shangji is the LED that I used. I bought a vast quantity. I think I've got 5,000 of these in various colors. I picked them up very inexpensively from, you know, AliExpress. There's slightly nicer versions that are available from Mosier and DigiKey. I also use a true reverse mount LED, but that's for a different project. And for that, you actually have to have a hole in the middle. For these, you don't. So my original footprint is this trick you see right here. And I mentioned it, I think, on another call. So what I did was I created, and you're going to see it if I get really, really close, that little dot right there is actually an SMD pad with almost no size. And then it has a pad clearance to basically remove all the copper and mask from that location. And then this outer one is on the other side. So the first one I showed you there, that was on the front side. And then if we look at the one that's on the back side, it's the same thing, except it has a much larger clearance. And so if you place that LED on a printed circuit board, what you would end up getting is a small spot with no copper and no mask on one side, and a large spot with no copper on the other side. But if you want to then do, as in this example, if you want to do some, you know, very interesting shape and it's got some coloring and stuff in it, I created another version of that, which it only has half of that whole process. So it has the same trick, but now it's only on the front. It's only on the front side copper, and it assumes your artwork will remove the mask and the copper from the back side. So that's kind of how I ended up creating that little LED that you see right there, which is this one right here. Okay, so let's take a look here now, and Oops, I didn't want to do that. I want to do this. Just want to quickly show you that indeed, if I do a copper pour on my front side copper, and let's assign it to ground. Oops, try that again. Doesn't need to be perfect, just needs to get around here. There we go. That indeed the copper pour is following that shape that we created. Creating the shape within KiCad is easy if it's a rectangle or a circle, but it's much easier to just create this in Inkscape, so you can create any shape you want. And then if we just quickly, I'm just going to flip this so you can see how the artwork lays out on it. And mask. And I'll just get rid of the flow. So now you can see I'll flip the board. You can actually see where the text is going to be, how the artwork is going to be, how the LEDs are lined up underneath it. But you'll notice that if I actually look at the copper layer, I didn't clear any copper out. All I've done at this point is just simple artwork. So now if I want to actually clear out the copper on these, let's go back to Inkscape here. There are a few tricks, so I'll just do these down here since we're running long on time. Let's say I wanted to remove these from the mask and remove these from the copper layer. I'll do a quick duplicate. Oops. Did I duplicate the right thing? Yes, I did. Sorry. Get these. So right now, these are just artwork. I don't actually want them to be artwork. What I really want them to do is I want them to remove the mask, and then I want them to remove the copper. So I've moved one copy of these to the mask layer. I'm now going to move one copy of these to the copper layer. And just so you can see it, let me hide all the silk and hide the edge. And let's look at just the mask layer. So now we're going to be adding we want to have output from the mask layer, and we want output from the copper layer. So let's just start with the mask layer. So all I want to do here is this will now remove the mask because these are all solid. And now let's look at the copper. What I really want to do here is somehow I have to remove the copper. And this is a bit of a kludge, but it actually is a kludge that works pretty well. Unfill these and create a width of a stroke. This, I believe the trick here is this has to be wider than the set for your design rules. But we're pretty good here. So now what I have, let's come back to, let me come back to my layers, and I'll turn everything back on so you can see it again. And here's where it kind of comes in handy to potentially use some color here. And there's only one limitation on the color. It can be any color you want. The SVG plugin will filter out anything that is a transparency below a certain threshold, and you can create it. So that's a handy thing if you want to put notes on here, reminders, if you want to have reference points on here, but you don't want that to end up in the footprint, just set their transparency to something below half. That's the default. But let's just make it so that we can actually see this. I'll make this, I'll just quickly make these red just so you can see them. Now you can get an idea of how this is going to work out. So We save this, we go and we regenerate our footprint. And actually, when it comes back, I'll show you what I was referring to on the transparency. Right here is the default threshold. So anything above 128 out of 256 will be part of the footprint. Anything below that will actually just be ignored. So if you wanted to put some comments on here, some reference material, an example that I've used is if I've already pre-designed the board, and let's use, say, for instance, there's mounting holes. I can actually create an SVG in KiCad, import it into here, set the transparency threshold below 127. It will be on my artwork, but it won't end up going back over as part of the PCB. So now if we go in here, we're just going to do tools, update footprints from library, update them all. Now you'll actually notice that I've wiped out both the copper and the mask where my LEDs are in this particular location. And then I would go and do the same thing for this logo. So I've taken more than I thought I was going to take, but I wanted to get into, 2 or 3 of the features that I use all the time. One is just the ability to put artwork on a PCB. And I've done some somewhat crazy ones. No, I don't want to save this particular footprint. So I was actually doing a test board and I wanted to just try out some ideas. So this was a backside silk layer on a board that had nothing on the backside anyways. This top one gives you an idea of how that zebra trace trick can create something that looks a bit like a picture. It looks a little more like a picture when you zoom out. But for what we just created here, I now have my artwork on my PCB and I have a custom cutout, so I can do all sorts of shapes, which is kind of nice. You can see this might be kind of handy if you wanted to do an electronic business card that was just not a rectangle, something a little bit different, but was in the same general size and shape. And you can remove copper and you can remove mask as part of your work. So questions?
Do those mask and copper removed render nicely in the 3D viewer?
Oh, actually, that's a really good point. This is going to look pretty horrible, but why not? Let's just do a quick. Where's my 3D viewer?
I'm no longer seeing your screen sharing either.
Oh, I must have clicked on the don't share my screen anymore. Let me, there we go. So you can kind of see the board. I've actually created a 3D model so that my piezo buzzer and even these LEDs actually all show up correctly. But to your question, there's the board. And you can even see, the LEDs will shine through here. And I would go and do the same trick for this one, but I just didn't do it during this demonstration. But yeah, it actually works through. I can quickly give another example.
Did you set an option to show the solder mask in red there?
Oh yeah, in that particular case I did because I think the last board I looked at in the 3D viewer was the Christmas bell, and it is a red PCB. So that's why that one happened to be in red. When I do my 3D view, I use it as a sanity check at the very end. So a lot of times I'll make the PCB the same color as the actual project I'm working on.
Yeah, it's an option I hadn't come across. It's really nice.
Yeah, and I can show you where I do that real quick. This is the project got me all started on this thing. And this is not overly complicated as far as electronics is concerned, but I needed to have edge plating, and it's a 2 millimeter thick PCB, and there was a bunch of things on this one that were a little bit more interesting and challenging. But this doesn't use any of the removal of mask or the removal of copper, but it was what got me started on doing all the artwork, because I needed to be able to accurately place everything on this one. To your question, you simply come up here, do choose colors, solder mask color. So this particular actual board is actually in black. So just, 0, there's my black. And give it a second. What's causing this one to be so slow on the repaint is actually the Spirograph example in the middle of that. It creates for a very large footprint when you start doing that kind of a trick. But so here's this particular coin project that I'm working on. This is the one that uses, let me flip it all the way back around. This is actually using true reverse mount LEDs. So these LEDs are meant to be mounted into a hole, and then they shine through the other side.
So you drill holes right through the board.
Yeah, the footprint for this actually has a through hole, non-plated through hole. The footprint's a little bit bizarre for this particular item. It's got a non-plated through hole, and then it's got pad A or pad 1 and pad 2 that extend quite a ways out from the side of the actual LED. A lot of people have actually just taken regular LEDs and mounted them upside down, but these LEDs were actually designed to be mounted upside down, and they work quite well, but they're not a commodity item at the moment. But you can get them in almost any color. You can also get, you'll notice, I think if I can just flip this a little bit the other way, you'll notice I actually have infrared and photo transistors in the same version down here. Back to the question, I'm going to stop screen sharing and then quickly look at the chat to see if there was questions that I didn't get to. So the question on the remove copper zone, you would get a better result if you were to do an exclusion zone within the PCB new. The challenge I have is when you start doing 10 LEDs, then you've got to create 10 unique, keep out zones in the PCB. And if you ever move an LED, then you've got to move that around. So while it's a better result than the kludge that I use of putting a tiny dot and then a big offset on it, at least with that I can move things around, and I can create a new printed circuit board and just drop 10 LEDs on it, and everything's working for me. There is one caveat to the trick I use where I put a dot and then a big offset. Is one time when I submitted that to the PCB manufacturer, the engineer got confused. I've used it 5 times. Once they got confused, and so I had to go back and forth with them. So what I do now is I just include a picture or a PDF of my board and circles and arrows and paragraphs explaining that they can ignore that dot. I'm looking through. I think this is it. That probably is the zebra trace. The great thing about zebra trace is you can actually get it installed. And I actually created a 60-second video on using zebra trace. It's over on my Instagram account. I create a fair number of actually full production videos on my Instagram account, and there is one on. So if you can follow it quickly, within 60 seconds, I run through the entire demo of. the entire demo of zebra trace, taking a black and white picture, doing zebra trace on it, creating an SVG, taking the SVG into Inkscape, and then Inkscape to create the footprint. I'll try to find one and stick it in the chat. And I think that's all the questions up to this point. So I'm going to stop talking.
Thank you. That was really useful.
Well, my first question is, can everyone hear me? I've had a bit of a trouble.
Yeah, you're back.
Yeah, okay, so I changed over from Chrome to Firefox. Chrome was going crazy with this, so I could. Apparently, it was denying permission to use camera and mic and all of it. This was awesome. I missed some of it because I was trying to figure out where I had gone wrong with my settings here. But I'm sure I'm glad we have the live recording to go back on and refer to this. But amazing tips, Braden. This was so helpful. I had one question, Braden. When you take a edge cut outline in Inkscape and bring it into KiCad, does it import curves as line segments or as arcs?
Sorry, I needed to unmute. So the answer is there's actually an option to do the conversion. So when you do the second step, the export to KiCad, there's by default it's checked and you want to keep it checked. It says auto flatten Bezier for edge cut layer. So it actually does segment the whole thing. And so it can take fairly complex shapes and create usable edge cuts. There is one issue that I've had when I do this, which is if I want to have a hole within the printed circuit board. So if the edge cut layer is not just an outline, but it actually has a hole in it as well. I can quickly go back and show my screen. I'll show you an example of where I did that here and here. Where was I? I think I've got way too many windows open now. Oh, actually, I can open it from here. I can open it from here. There we go. I can close that off. Home F5. So if we look at this particular, I'm hearing somebody else. Thank you. So if we look at this is a new cool project I'm working on. It's another sort of puzzle badge that I created. The edge cut is actually this rectangle with the rounded corners, but I also wanted to have this hole cut out of it. When I generated and I'll even show you the mistake that it makes. Open recent KiCad B Silk. So here it is. I've flipped it around. You'll notice that to make my life easier to see, because this is going to be a red board, I did a fill. And as I told you, if you set the transparency below 128, this fill will actually not be part of the footprint. So if I then went in and took this and generate my output, I want to make sure it's going to the right location. Yep, cool. This one will take a little bit of while because this is actually doing all sorts of interesting stuff where some of it's on the silk layer, some of it is on the, where are my footprints? I'll just, whoops. Let me close a few of these. Let's get rid of that one. So when I do one of those, there, you'll actually see the error right now. So I've opened up that footprint that we just generated, And you know, you can see down here, I'm removing copper, I'm removing mask, I'm doing a bunch of different things. There's this extra little line. So if you do a hole within your edge cut, this is the only mistake that I found. There may be a fix out there somewhere, but all I have to do is I have to go into here, delete that, control save. Now if I do a flow, it will actually, the copper fill will fill this whole area, and it will leave a hole right here on the printed circuit board. That's the only mistake I've found in using the tool, is if you want to do a cutout within a printed circuit board, you end up with that issue. But yes, it does actually go and create, you know, a big polyline for the whole thing. Matter of fact, if I were to go in here, you'll actually see there's a line segment. There's a line segment, and it segments this whole thing, as opposed to trying to create primitives that KiCad recognizes. It just creates tiny little line segments out of everything. Which, by the way, is why you can imagine this footprint is huge, because these are all tiny little line segments.
Awesome. That was great. Any more questions, anyone?
I was just going to share an experience I had trying to use that SVG to Shenzhen plugin. I was using it actually on my work Windows laptop, and it was squashed by the security software because it had a call to an Amazon Web Services box in the code, which it didn't like. I've not tried it running it on a Linux box to kind of get around that. I was just trying it on the laptop I had in front of me at the time. But I did find that for single layer stuff, so just doing silk artwork, I actually found I could just export from Inkscape as DXF, and you can import DXF directly into the footprint editor in KiCad. And that enabled me to get some quite complex artwork onto my silk layer.
That's actually how I did my very first one, was through DXF. The challenge I had when I was doing that was, if I wanted to scale it again, then I had to find a way of scaling it before I did the generation of the DXF. And what really pushed me over to the plugin, though, was dealing with text and also dealing with the retrace example. But yes, the DXF method to create a footprint works well for anything that generates a DXF natively. My CAD software that I was using, I use Fusion 360, generates non-compliant DXF that KiCad can't work with, or KiCad can't work with. So that was kind of a hiccup I had. But a lot of people do the DXF model, and it works quite well.
Yeah, I've found quite a lot of programs generate DXF that you have to open it up in Inkscape and then save it back out again to make it compatible.
Jeremy, you had a question?
Yes, when you're exporting DXF like that, I've done that before, but it seems like when you try to do the edge cuts with that, the line thickness doesn't necessarily line up with what you have in KiCad. Do you have a number for that, or some way to get that to align correctly? I guess it's more of a visual thing than anything, but it just bothers me a tiny bit. Hello?
I'm not sure who the question was for.
Oh, I guess anybody who knows.
Oh,
I
okay.
guess you, Braden.
Well, actually, I don't know, because I never really was that successful with the DXF model, and as soon as I started doing very complex artwork, I stumbled across this plugin. I know it's possible. I know a lot of people are very successful at it. I'm just not one of them.
Okay, well, that makes sense. It's
I'm not sure, but in PCB New there is a edit graphic properties uh, box that might let you change settings globally, which means select all items on edge cut layers and set their thickness to X mil mm.
okay. Thanks. I'll have to play around with that a bit.
Yeah, I haven't tried it, but I'm guessing that would work.
Okay, thanks.
The one trouble I've had with let's say having an edge cut flare with line segments for arcs is it becomes difficult to find the center point, especially when you're trying to get this exported to mechanical CAD uh, modeling, like for example into FreeCAD, and then you want to build enclosure around it with mounting holes and stuff like that. If you don't know the center of the arc, it makes things more tricky. So I prefer if there is a way to get DXF import with the arcs rather than have it broken up into line segments.
You can try to not have it flatten. So if you remember that dialog box, I had it checked for flatten.
Yeah.
You can always just give it a quick try, uncheck that box, export it. I've had, for relatively simple outlines, it's worked pretty well. It's not worked for my more complex shapes. The bell was an example. The snowman was an example. They just didn't work out. But for a basic circle or a rounded corner, I think it does work pretty well.
So my experience working with HPG to Shenzhen is if you rather go to the extension, modify path and add nodes, that works way better than flattening the Bezier.
Come again, Ian.
It also reduces the export time, so you do not have to pick that.
Could you repeat that? I didn't quite catch that.
Yeah, so in the Inkspace, there's an extension called add nodes.
Okay.
Modify path. If you use that, it will add a lot of small nodes in your edge cut layer, and that will allow you to export complex shape without using flatten Bezier option for FPG to Shenzhen. That also reduces the export time, and you can have more DPIs.
Okay, that's nice to know. So essentially, a couple of options to play around with in SVG to Shenzhen that might help things. That's good to know. Awesome. That's been, I think, a great hour. I guess we've crossed an hour, but I'm happy to keep going if there are additional questions or people still need to ask something.
Regarding the whole path, you can use a registration layer for that. There's a video where you talk about the registration layer, and you can get a reference from where you can put the holes for 3D model.
Okay, that's another handy tip. Maybe that could work.
Yes, I'll post the link.
Yeah, I've had some trouble recently with, especially I think Drew will remember the badge that we made for the Open Hardware Summit 2020. The outline for that was a DXF import, and that made life pretty difficult in terms of the CAD modeling part. Not so much so in the KiCad side, but when I brought things over to FreeCAD, I was having a lot of trouble determining the exact dimensions and so on. In fact, the badge used a kind of a different approach. I think it was Michael Welling who did it. And what he did was the he took a DXF and converted it into a footprint as an edge cut, which really wasn't the best way to go, but eventually it all worked out.
Yeah, so in this video there you can see about the registration layer. So basically how it works is, suppose you're doing some molding and you design a mold with the holes so it aligns perfectly. So that is the concept. You have a registration layer and everything aligns perfectly. And when you are done, you can delete that layer in the KiCad at a later stage.
That is nice. I should check that out. Anyone want to share some quick tips and tricks that you'd like to throw out before we wind off?
Thank you for organising this. It's been very illuminating.
Well, thanks everyone for dropping by. I'll announce.
Anil, what would have been the correct way to do the outline?
Let me think about it. So I would definitely do it using the KiCad primitive, so arcs, lines within KiCad. I would use the DXF import as a template.
So you bring it in and then lay it out in KiCad and then delete the like put it on like Eco or something like that and trace it.
Something like that. And then I would try and make sure that the dimensions are nice round numbers instead of like nanometer scale numbers.
Right.
So sometimes even with the DXF import, what is supposed to be a vertical or a horizontal line actually comes in as a slightly tapered or slanting line that ends up causing. In fact, that was the case with the badge outline too. So I would use that, and then using the numbers I get out of FreeCAD in terms of the arc, radius, and center point locations, it would then be easy to reproduce it in KiCad, or in fact, even an export from KiCad would give you a nice edge cut layer that you can play around within. For example, if you're working in FreeCAD and you want to do use the step up workbench to edit the outline, for example.
Right. Yeah. By the way, can you hear me at this mic level? I've been trying to play around with some settings.
Can, but it's pretty soft.
Okay. Is this better?
Way better.
Okay.
Yeah, we are all trying to get our work from home settings.
Yeah.
I think. I've got the washing machine going on behind me.
Can you see my screen? I'm sharing something.
Yeah, you can see it.
Oh yeah.
So suppose there's a circle, and suppose we want to do some red kind of shape. I can combine these both objects. Here I'll go to the path. I'll do a union. Suppose I want this as my edge cut. So now, first of all, since this is the shape, not the path, we need to convert it into the object.
Yeah, convert shape to object.
Yeah, so now we have a path, but since it's very difficult for the KiCad to render these curves, there's a small extension here which we can use. So it's called modify path and add node. And if you go here, you can add node to every one pixel. So I'll apply this. Now, if you can see the Bezier tool, you can see there are a lot of nodes has been applied. So these are the nodes here. So now it's more easier to export using HPG2 engine, and you do not have to use this this option anymore. And you can also go to 1200 DPI. Yeah, so that's a neat hack.
Oh, that's super cool. Nice to know that.
How do you decide what DPI to use?
More the DPI, the better the resolution your PCB will get. So 600 is the minimum for a lot of the board houses, but I have get really good results going 1200. If you are using the true SVGs, then going 1200 will not be an issue, and you'll get better results.
Okay.
Does that change the dimensions in any way?
No, it's like dots per pixel, so
Okay.
it increases the number of dots in each pixel.
Got you. Okay. All right. You have a link for this tool on for this extension for Inkscape?
So this one is built into Inkspace as well.
Okay. Okay, got it. Awesome. I learned a lot of stuff today, so that was a fantastic round of meetup. Thank you everyone for joining in. We can do this again next week. Same time, same place. I'll put details up on Twitter and Facebook and KiCad forum and everywhere else. And if anyone wants to, show a trick or a tip like Breda did today, feel free to let me know. And it'll be, I think, a nice way for all of us to learn new tricks. So give a shout, and I'll add the details when I make the announcement. Thanks everyone for joining in. It's been a great hour and a half of this meetup. See you next week. Ciao.
Thank you.
Likewise.
Thank you.
Thank you.